Hi everybody, today we are going to be talking about some terminology from section 5.2, which is Introduction to Graphs. So first things first, what type of graph are we talking about? So we are talking about dots, which we call vertices, connected by lines, which we call edges. Okay, and it should be noted here that the shape doesn't particularly matter. All that really matters is what's connected up to what. And it doesn't matter that this edge is nice and round and this one is straight. We could have just as easily drawn this graph like this with a wiggly edge, or had this one come way out here and the loop be really funny looking, and had this edge be all zigzaggy. Okay, so what matters is which vertices are connected up to which. And see, we've labeled each vertex A, B, C, D. In both of these pictures, all the same connections are made. This one's just drawn a little more wiggly. Okay, vertex set of a graph. It's just a list of the vertices. So in our example above, our vertex set would be A, B, C, D. And adjacent vertices are vertices that share an edge. So for instance, in the graph above here, this purple graph, A is adjacent to B because they share an edge. And A is adjacent to C because A and C share an edge, but it's not adjacent to D because A and D aren't connected up by an edge. And we should note here, B is adjacent to itself. And that is what we call a loop. A loop is an edge that starts and ends at the same vertex. So it looks like this. Okay, the edge list is the list of edges that we've got. So let's redraw our graph above. A, vertex B, vertex C, and vertex D. So we're going to list up the edges by what vertices they connect up. Okay, so first we can deal with this edge. That's edge AC. Then we've got this one. We're going to list it twice because it's drawn twice. Then we've got AB. And that loop goes from B to B. So we write from B to B. We have an edge here from B to C. And we should note we could have written it as CB. We're not dealing with direction on the edges, so the order that we write these in doesn't matter, but usually we're going to do them in alphabetical order. All right, and then the last edge on the graph is CD. Okie doke. Let's now introduce some other terminology. The degree of a vertex is going to be the number of edge ends hitting that vertex. Okay, and I say edge ends because a loop counts twice. So for instance, this vertex here, we've got one edge coming in from the left, one coming in from below, and then that loop hits it twice. So this one has degree 4. Here, we've got 1, 2, 3 edges. Here we've also got 3 edges, 3, and 3. All right, odd vertices have odd degree. So we have 4 odd vertices in this graph, and even vertices have even degree. We have just 1 even vertex, the one here with the loop. Okay, a simple graph has no loops or parallel edges, and by a loop, let's recall, we mean an edge that goes from one vertex back to itself, and parallel edges are edges that connect up the same vertices. So for instance, this is a simple graph. This is not a simple graph because it has these parallel edges here. And it's any number of edges. So here's 3 parallel edges, here's 2 parallel edges. They still prevent it from being a simple graph. Okay, a disconnected graph is one where you can separate it into 2 completely different parts that aren't connected by any edges. So here we've got this piece, here we've got this piece. We can separate it into what we call components that are not connected by any edges. And a connected graph, we can't do that too. So we see in this graph here, there's no way to redraw it so that there's a piece separated off. Okay. All right. And let's talk about adjacent edges. So adjacent edges are edges that share a vertex. So for instance, edges 1 and 2 are adjacent in this graph because they share this vertex, but edge 1 is not adjacent to edge 3. Edges 1 and 3 are not. They don't share a vertex. Okay, components are the pieces of a graph, the basic pieces. So for instance, on this first graph in blue, we see we've got 2 components, right? You have 2 pieces that you can separate off that aren't connected up by edges. Here we just have 1 component. And you're always going to have 1 component when it's a connected graph. Okay, and a bridge is an edge whose removal would disconnect your graph. So let's take a look at this graph here, and we'll see we've got 2 bridges actually. So our first bridge is this one. Let me see if we just erased that edge entirely. Let's just go ahead and do that. If we erase that edge, we've got 2 totally separate pieces. So that is a bridge. And we've got another bridge over here. Because we're erasing only the edge, not the vertex. So if we erased this edge, we'd have 1 component that's the single vertex and 1 component that's the rest of the graph. So both of these are bridges. And that is it for today.